Hi, Southwoods Algebra fans. I bet you were wondering, where would we use quadratic equations in the real world? Mrs. Lindsay here to talk to you about that. So let's get started, shall we? What could be more real world than our ages? So we have two siblings here, Ayala and Yusuf, that are two consecutive odd integers. Now, if Ayala is x years old, we know two consecutive odd integers are 2 units away from each other. So Yusuf, being apparently the older sibling, would be x plus 2. So Ayala is x, Yusuf is x plus 2. And now we talk about the future in 3 years. So in 3 years into the future, Ayala is going to be her present age, x, plus 3. And Yusuf is going to be his present age, x plus 2, plus 3. But wait a minute. 2 plus 3 is 5. So let's just combine 2 plus 3 and make his future age x plus 5. Now, in the problem, they talk about the product of their ages, the product of their current ages, the product of their future ages. Well, I decided to make another row for product, which means multiply. So I'm going to multiply their current ages, x times x plus 2, right here on the chart for convenience. And I'm going to multiply their future ages, Ayala's x plus 3, times Yusuf's future age, x plus 5, and we've seen that before. Two binomials multiplied together. Now, in the problem, it says 3 years, in 3 years, the product of their ages. Well, I have that right here. So I'm going to write in my equation x plus 3 times x plus 5, because that's the product of their future ages. Then it says will be. Will be is a form of is, or equals. When you see that, you write down an equal sign and start working on the right side of the equation. And here in the problem, it clearly says 10 more than. Well, that means we're going to add 10 to something. And that something is what comes next. Twice, that would be 2 times the product of their current ages. Well, here is the product of their current ages. X times x plus 2. Okay, now I'm going to just simplify and solve. To simplify, I'm going to either FOIL or box, and I think I'm going to FOIL because it seems simple enough. X times x is x squared plus 5x plus 3x plus 15. And on this side, I'm going to distribute the 2x. So I'll get 2x squared plus 4x plus 10. And I think I'll combine like terms here. So I'll have x squared plus 8x plus 15 equals 2x squared plus 4x plus 10. Well, you see that I have a degree 2 equation to solve, and that means I have to set it equal to 0 using the 0 property of multiplication. And the easiest side for me to clear out would be the left side, because I have the least x squareds here. If I subtract x squared from both sides of the equal sign, I'll still have a positive x squared here. And that will make it easier to factor. And I think just for saving space and convenience, I'll subtract 8x on the same line because I'll have to get rid of all the terms. And the subtraction property of equality, I'll subtract 8x on the other side. And I'll subtract 15 on both sides of the equation. So I'll get 0 with all these additive inverses on the left side, and I'll get 2x squared minus x squared is x squared. 4x minus 8x is negative 4x. And 10 minus 15 is minus 5. And then, to factor, because it's a quadratic equation, I need to factor this into two binomials. Since my lead coefficient is 1, I can use add multiply. So I split up the x squared, x and x, and I find two factors of negative 5 that add to negative 4. So negative 5 times positive 1 multiplies to negative 5 and adds to negative 4. As I tee it up, I set each of these factors equal to 0. X minus 5 equals 0, x plus 1 equals 0. So if, indeed, x minus 5 equals 0, that would mean x would equal 5. Well, let's see. Could that be Ayala's age? Well, sure. Ayala could be 5 years old. That would mean Yusuf would be x plus 2. He would be 7. Well, that could be Yusuf's age. Those are plausible ages for Ayala and Yusuf. But if my other factor, x plus 1 equals 0, I would get x equals negative 1. That is not plausible. Nobody can be negative 1 years old, so I reject that solution. So, my final answer, Ayala is 5 years old, and Yusuf is 7 years old. The ages of two siblings who are consecutive odd integers. Let's do another. Another situation we can have in the real world is a border problem. So if the Kims have a rectangular pool, as drawn below, that measures 12 feet by 20 feet, they are building a walkway around it of uniform width. Now, when we build a walkway around a pool, if here's our pool, and our walkway goes around the pool, it actually increases the length and width on both sides of the length and both sides of the width. So we don't simply add x, we add x and x again. So we're actually adding 2x to the original side of the pool, to the original length of the pool. So we're adding 2x plus 20. And the width is the same. We're going to add x on both sides of the width, which is 12. So we're actually going to have a walkway of 2x plus 12 from here to here. So the area of our pool is going to be length times width. The area of our pool will actually be 2x plus 20 times 2x plus 12 will equal 660. So probably the easiest way to solve this, we can box or foil it. I'm going to foil it to save space. 2x times 2x is 4x squared, plus 2x times 12 is 24x, plus 20 times 2x is 40x, plus 20 times 12 is 240, equals 660. I'm going to combine like terms, and I'm going to subtract 660 from both sides because I need to set this equal to 0 because it's a quadratic equation, it's degree 2. So that'll be equal to 0. I'll get 4x squared plus 64x minus 420 equals 0. Now you could try to factor this. It would be quite difficult. Or you could do the proper thing and find the GCF. And if you notice, the GCF in all of these, since they all divide by 4, is 4. So my GCF is going to be 4. 4 will factor out of each of these 3 terms. So we'd end up with x squared plus 16x minus 105. And now it's a simple add multiply. 4 is my GCF, and my trinomial factors into 2 binomials. Split up the x and x, and 2 numbers that multiply to negative 105 and add to 16 are positive 21 and negative 5. When I tee this up, interestingly enough, my GCF, my 4, can't possibly equal 0, so I just ignore that. X plus 21 could equal 0, I guess, and x minus 5 could equal 0. But if x plus 21 equals 0, I would get a border of negative 21. Well, that I need to reject because I can't have a negative border. It's a geometry problem. It's a rectangle. So my only answer is x has to equal 5. Okay, so let's see. The border has a width of 5 feet. Wide. Now they also ask, what's the new length and width of the pool? Well, if the border's 5 feet wide, 2 times 5 plus 20, I could now say the new length is 2 times 5 plus 20, which is 30 feet. And the width, let's see, the width will be 2 times 5 plus 12. The new width will be 22 feet. So another real-world problem, border problems. This is Mrs. Lindsay signing off. See you all tomorrow.